The interactions between climate and air and climate and sea can often have strong impacts on annual weather and sea conditions. This presentation will be focusing on two patterns, the North Atlantic Oscillation and La Niña, and the impact they have on weather conditions and ocean temperatures. Now, first we'll discuss the climate and air interactions focusing on the North Atlantic Oscillation, or NAO. So what is North Atlantic Oscillation? NAO is an interaction between subtropical high-pressure systems and Arctic low-pressure systems. These pressure systems control airflow along Western Europe, Africa, and the East Coast. North Atlantic Oscillation results in changes in temperatures in the Arctic Ocean, as well as the location and strength of the airflow. The location and strength of airflow can result in varying weather conditions. Now, there are two types of North Atlantic Oscillation, positive and negative. Each oscillation has a different impact on the weather conditions and sea temperatures of specific areas. These phases vary from decade to decade. The positive NAO phase is marked by strong subtropical high pressures and weak Icelandic low pressures, as well as a wintertime northerly jet stream over the Atlantic that is stronger than normal. The result of this is a milder and wetter climate over the Northeast and Northern Europe, a cold and dry climate over Canada and Greenland, and a dry climate over Africa and Southern Europe. The positive phase of NAO was seen throughout the 80s and 90s, however, it is always very difficult to predict. The negative NAO phase is marked by weak subtropical high pressures and weak Icelandic low pressures. Reduced pressure results in fewer and weaker storms that cross from east to west. It also results in more cold outbreaks and snow in the Northeast, mild temperatures in Greenland, cold air in Northern Europe, and moist air in the Mediterranean. Like the positive NAO phase, it is very difficult to predict. This graph of the North Atlantic Oscillation since 1860 reveals an inconsistency in the positive and negative phases. Looking at these patterns, however, can help us understand warmer or colder winters. While climate change is a huge issue currently, the graph shows that the NAO patterns may have a strong impact on a particularly warm winter. Now we'll discuss climate and sea interactions, focusing on La Niña. La Niña is characterized by especially cold temperatures in the equatorial Pacific. During La Niña, strong wind patterns push warmer water in the western direction, allowing deeper, cooler water to move towards the surface in the eastern direction. When the water moves upward toward South America, it carries many nutrients up with it. This upwelling is extremely important for fishermen in South America. The result of this shift in warm and cool water is warmer temperatures near Indonesia and cooler temperatures near the Pacific Basin. La Niña, which occurs every 3 to 5 years, can result in wetter conditions, especially in the U.S. Generally, La Niña lasts for about 9 months, but sometimes can last as long as 2 years. Specifically in the U.S., the westward moving jet stream can result in storm tracks and hazardous weather, especially in the Great Lakes region. In the Northwest, climate is wet and cooler than normal. In the Southwest and Southeast, climate is dry and warm, and in the Great Lakes region, the climate is very wet and cool. Hazardous weather generally occurs in this area because the Great Lakes region is the target for the jet stream.